Mm, Hello, everyone. Thanks for being here today. We are Team 21, RJ, Xunan, Smithy, and I'm Joy. We come from different backgrounds, but we share the same vision, using technology to save lives during disasters. And today, we'd like to share our journey with you. Okay, let's start with a scene. Imagine you are a firefighter. You just arrived at the disaster site. People are yelling for help, but you have no idea where you are and how to reach them safely. In that chaos, what you need is not more information, but the right information. So we ask ourselves, can AI help us see the whole picture and actually guide us through it? Our answer, yes. We built an AI-powered system that automatically gathers and consolidates real-time data, updates the situation evolves, and most importantly, give clear, robust instructions to help rescuers act faster and smarter. Also, we use UW's campus map as our prototype since we are all students from UW. We designed the system to operate like a real-time brain for disaster response, and we are excited to show how it works. And now I will hand it over to RJ.
So let's check out how our system is designed. So we rely heavily on four main agents to help people rescue from help us to rescue people from an emergency situation. Those four agents are sensors, communicator AI, commander AI, and workers. Sensors are basically the eyes and ears of our system. They provide the much needed information that we require to save anyone from the emergency situation. We have divided the sensor into two parts. One is drones, which are mobile applications which are mobile systems that are going to be sent out once we detect an emergency situation. And the other ones are IoT devices. They are the dumb devices that are present there. They are pre-planted and they provide the constant information throughout the year to the commander AI so that it can be reserved and saved for historical data. These sensors provide information to the communicator AI. Communicator AI, the main responsibility of communicator AI is to gather and merge the information to pre-process it for the commander AI, to dispatch the information as it seems deems necessary, and take actions that commander AI has asked the host system to. Once the computer AI processes the information, it transfers it to the commander AI. Commander AI is the brain of our system. It generates the map, analyzes the situation, collects the historical data, and based on the historical data and the training done, it takes decisions, creates actions, and decides on routes. All these information are converted into task and is provided to the computer AI. Communicator AI decides on how these actions are to be performed and are to be performed by whom. They are then provided to the workers. Workers are basically our legs and hands that are there on the ground. They get these actions. They take they take the required efforts to make to help to save the victims, and they provide the feedback back to the communicator AI so that it can provide better response. Communicator AI is also responsible to relay the information to the emergency services and so that they can clear up space in hospitals as well as call the ambulance to the right exit points. I'll hand over to Smriti.
Yeah, thanks, Rishabh. So, on brainstorming, we decided to present our solution in the form of a 2D game simulation, a grid map resembling a reference example location of the University of Washington quad, which would not only visualize the starting and growing fire hazards, but also the victims, rescue bots, and safe zones, and the obstacles that come with a natural disaster. The idea was to use all these parameters in a perceived map to then make decisions about the best optimal route that can lead the victims to safety. We therefore use this base to build a commander AI, which serves as the engine of our solution to enhance agent navigation, obstacle documentation, and rescue operations. Og?
Hi. Then I will walk you through the Commander AI. First, we will begin with the inputs. They will have all the information we gathered from the perceived AI, like the uh, victim rescue and generated their remaining health point. Because in our settings, they will, if this health point drops to 0, they will die. And also their current and the predicted locations. We have predicted locations because we don't have enough drones to have sight over everywhere. So we cannot know exactly whatever was going on. So we use our information about the predicted their locations to help us make informed decisions. And then we also have the obstacles locations and as well as the headers locations and there are several levels because there are several different levels for this. If they the height level will kill the rescuer and victims immediately. Then second part is our algorithm. We mainly basically do this in two parts. The first one is the way we just optimize our routes for each of the victims and each of the rescuers because by this we have all of um, sorry, let me begin with that. For every pair of the victims and the rescuers, we calculate how many possible routes they have to reach to each other and also get out of a map. Then we will calculate the, customer scoring, like the likelihood of successful execution of the task. This will to calculate not only the efficiency of the roads, but also the risk of the roads, like is there any nearby headers, and also the opportunities they have when their path is blocked and they want to drop to a backup plan. Then overall, we have the likelihood of the successful execution of the task. Then we can pick up the route, the optimal route with the highest likelihood of the successful execution. Then after we having this, we will try to prioritize our tasks. So we will calculate another benefit cost score, which is the task's successful execution likelihood minus the risk of losing the rescuer because every task they will put the rescuer into danger. And then also the expectation of the numbers of victims being endangered during this time. Because if we are trying to letting our rescuer to save this victim, they will cost the opportunity cost of the saving other victims. So this some factors we want to calculate. Then after we calculate this score, we will pick up the task with the highest benefit cost score. Then then we will they will assign the task to their victims and also their to the rescuer to save these victims. After that, we get our outputs, just like the prioritized tasks like the victims and their paid rescuers, and also the drones, because drones are supposed to support them to find out the updated information. And also, as we have the optimized routes for this pair of victims and the rescuers. Then I will hand back to the Smithy to, yeah.
Okay, so thanks all. Let's just quickly see a quick demo for our solution. So this is, as we mentioned before, this is the grid map resembling a UW squad. The red zones are the growing fires. Black spots are the obstacles. Blue dots are the agents that are trying to find the clear paths to rescue the yellow victims. The green area here is the safe zones, and their task is to find a way to a clear path towards the safe zone. So this is what our solution is doing at the moment. Once the whole thing is run, This is what Commander AI comes up with as an output. It locates the location where the obstacles are. It locates where the clear paths are, detects the obstacles, the hazards, and then finds the rescue paths as well. It also creates no this is a part of communicator AI, which creates a message log, which is used to communicate between these systems. And this is the result from our simulation, wherein it like tells how many victims have been rescued and unfortunately how much have been lost. Nick?
All right, in this slide, we focused on the ethical issue involved in our multi-agent rescue system and how we aim to address them through the involvement of human intelligence. So first, let's talk about ethical challenges. So our AI decision-making approach is rooted in the utilitarian logics. So it means like we aim to save the greatest number of lives by prioritizing those who are in the most danger and least likely to self-rescue, while balancing the dangers that rescuer may face. And this approach maximize efficiency. It also introduced a serious ethical concerns, which is individuals who may not score high on this matrix, such as victims who are slightly more stable, easier to reach, or too dangerous to rescue, might not be prioritized. However, from a human rights perspective, their lives are equally valuable. Even though we try our best to realistically simulate hazards and victims' condition, real-world emergency are dynamic and situations can shift rapidly. And an AI's decision based on a statistic snapshot may become outdated or inaccurate in real time. And that's why we need the involvement of human intelligence. So our mitigation strategies focus on integrating human intelligence into the loop, particularly through the expert consultations or and the final human approval. We ensure that AI does not operate in isolation and it supports human decision rather than replace them. And below it's our simple version of roadmap demonstrating the information flow from gathering, decision making, decision transferring, and the final human approval on this rescue decision. So in the final step, a human decision makers, likely rescue coordinators or an incident commander, review the AI's recommendation, and this person will use their professional knowledge or the context awareness to approve, adjust, or even override AI's plan.
Thank you, Nick. Now, after we presenting our solutions, I would like to summarize our unique advantage as realistic pain points, robust solutions, and smart algorithm. Realistic pain points means we focus on the bottlenecks of the disaster responses and tackle these problems with AI solutions, including impossibility for being fully prepared, since disaster could appear everywhere and probably cause huge damage to the local infrastructures. There is no way for us to get fully prepared, like in setting up enough fixed cameras or sensors to gather information for the disaster responses. Second one is the fast-changing environment and uncertainty disruptions. Situations change fast during the disaster. Fires or flood may spread or retreat. Passes may be blocked or in just a few minutes, which makes instructions infeasible if they didn't count in the new developments. The third one is that the instinct and the irrational victim response. Most of ordinary people without special training probably cannot act on AI instructions rationally. Then after we realize the pain points, we design our solutions to address these pain points, which makes our solutions robust. We deploy drones to get a real-time intelligence in the field. And since we probably don't have enough drones to surveillance everywhere, we predict what is going on in the area currently without a drone. And also our solutions, our instructions are optimized to maximize the likelihood of successful execution, which provides some level of redundancy for instructions to remain effective in the fast-changing environment. And then our instructions are designed for the rescue team and the drones at this stage, reducing the implementation complexities. In addition, we applied reinforced learning on the new developments in the field, which makes our algorithm smart. We calculated the average victim survival ratio in our simulations. If without any of the outside guidance, only 69% of them will survive. With non-enforced learning, guidance, the ratio raised to 76%. If we enable reinforced learning algorithm, this ratio further raised to the 87%. Now, the last we want to talk about our learning and our future improvements. Our learning mainly focus on the 3 points. The first one is that AI assumed a critical role in the rapid environment involving circumstances. Individuals must analyze this amount of intelligence prior to making a decision. So this task is almost impossible. So AI definitely help. The second one is the interaction constitutes a bottleneck in the AI implementations. Humans and other systems can only process only a limited quantity of information, especially during this emergency. So the exchange of information must be accurate and concise. The third one is that the ethical issue is very important. So we design this kind of second AI and the human approvals mechanism to tackle these issues. In terms of our roadmap for future developments, we think our first step will focus on the augmented impacts while expanding the use cases. We can save more lives and help more organizations, which will augment our AI system impacts as well as verify its business outlooks. So we have several areas we try to focus on. First, we will try to expand our guidance with more devices like ground robots, vehicles, and water robots. And then we can extend our function to supply logistics, like we can send drones or vehicles to transport food, medicines, and other supplies. And then we can to extend our information sharing to not only the rescuers, like also the victims, the media, and the victims' families. And then we can prepare medical treatments in the disaster, which will also be, I think, be some of use. And also we can offer some psychological comforting to the victims. After we have expanding all of our use cases, we can further expand our data sources, like we can connect more sense types and more identification abilities functions, like the sound, the seminal imagery. And then we can also connect more information, like human providing information, like social media. And number one, some people will ask for help via these platforms. And also we can connect to private devices after we given the permission, like the smart watches. Okay, that's all the thing we want to present. Thank you.
Thank you.
Thank you so much, team. I think first things first, congratulations. I've been looking at the progress you've made along the way, but it was just awesome to see how it all came together today, right? Very noble problem statement. You're saving lives, so that's the first thing I want to call out. The second is, I think you've thought through the problem statement holistically, so congratulations on that. And really good presentation too. Love the detail that you went into and the thought that you've all put into this. So congrats on that. A couple of questions from me, and then we'll go to Padma as well. If you go back to the architecture slide,
Okay.
I'd love to understand of all the models that you've spoken about, what were you able to accomplish from a coding standpoint that has been integrated into the simulation itself? So focus a little bit on that and tell us how much of what you've laid out here is what you've achieved through the last week or so.
Oh, sorry. Thanks, Pramod. Okay, so I'll just start and then the team can add on to it. So we did a lot of assumptions starting through our solution base. So the assumption was that we already know that a disaster is going to occur. So that means the sensors has already sent their data and everything. And most of our work was on Commander AI. So we prioritize that, performing concentrating on the pathfinding solution and everything. So once we did that, that is after that we went to Communicator AI, and some work has already been done on Communicator AI as well. But our main focus was Commander AI. Yeah. And if anyone
So,
wants to add, yeah.
so to extend to that, I think it was very well put by Smriti that we assumed stuff. So we wanted to focus on Commander AI because that was the brain of a system. Considering the time, we thought that we can gather data. So gathering data from sensors is pretty straightforward. So it was something that we already assumed that we have the data, we have the historical data, we trained it, and as soon as the drones are out there or the IoT devices are out there, they will provide the data during the emergency situation. The communicated AI was also pretty straightforward because it was responsible for like communicating between all the agents. It was also responsible for applying the decisions that Commander AI has taken. So we directly went to the Commander AI. We implemented our algorithms based on the data we already have, and we started creating decisions and actions that can influence saving the victims in the situation. When it comes to how workers will basically implement it, so we wanted to make sure that that the Commander AI outputs decisions on, like right now we are outputting it on command line, but I'm sure that we will output it in a way that the workers will be able to visualize it, and they'll have a better perspective on how to approach the victims. So we have when we talk about what we were able to achieve, so we were able to achieve the actions that is supposed to be taken based on the data, and how kind of visualization the workers will get, and they can work on it, and they can finally rescue the humans.
Awesome. Thank you for that. I do have another
Does
question,
that,
but I'll let Padma jump in
does
with
that answer your
any.
question?
It does. Thank you so much. And it seems like a reasonable approach to prioritizing the most important bits. Thanks for that. Um, I'll I'll see if Padma has anything that she wants to add.
I only have good words to add. So awesome teamwork they have done. I've been attending multiple meetings so far, and your one team has that, the teamness, togetherness. I could feel that. And I think Pramod said all the right things, like, you picked the right problem statement and you thought through everything from end to end. I think I like it. I don't want to, I don't think I'm good, Pramod.
Thanks, Padma. So
Well,
with 2 minutes, I'd love to ask one more question, right? So obviously the problem you have picked is one where the stakes are high, lives, right? Human lives. Perhaps it's the most important. And I like the ethical aspect that you have taken, where you've put a human in the loop, right? Because AI is where it is today, and a human in the loop is going to ultimately make the judgment. But the human is also being guided by AI. So how do you think about guardrails on the AI aspect to minimize, mitigate from hallucinations, wrong outcomes that it may propose, etc.? How do you think about that problem?
so coming back to the technical architecture, I think so. For every agent, we have mentioned configurations and dynamic configurations and rules that are basically the guardrails that we are talking about. So as soon as an incident happens, we know what kind of rules we want to apply to the decisions that we want to take, and these rules can be dynamically employed by any humans to make sure that it doesn't go out of bound. Also, like if we see that the situation is getting out of the hand and AI is not able to take the right decisions, then they can totally stop it, they can tweak it, they can guide it based on these configurations. So these are going to be very handy. These are going to be easily accessible to all the humans. Of the human that is basically uh, taking the decision of using AI to uh, to save people in the emergency situation.
Yeah, I just want to add one more thing on that because we also had a very deep discussion on that. It's not included in our solution right now, but as per the future aspect, we also thought about, well, once the firefighter is there, they'll have their own human instinct also because they have years of experience. So we will have bi-directional communication so that from the walkie-talkie they can send their instructions to the communicator AI also. Like we talk to Alexa, they can talk to our communicator AI. So that will also be considered, to reinforce the learning.
So now the human in the loop. Makes sense. Thank you so much. I think, again, finally, it was wonderful to spend these last 30 minutes with you all. I thoroughly enjoyed learning about how you thought through this problem, and I look forward to seeing all of you tomorrow in person.
Thanks.
I agree. I agree.
Same here.
Tomorrow's
Same here, Pramod.
tomorrow's
Thank you
plan
so
is
much.
please, yeah.
Thank
I
you.
encourage you guys to come and participate in the speed hackathon also now. You have one more too, and then while you guys are working, networking, that's the whole concept. The concept is fun.
Yeah.
That's what we are trying here. Thanks again. Bye.
Thanks, everyone. Bye-bye.